line from one point to the next. It's constant. So you could have said the same, you could have said constant, but because it's a line, it increases 2 up over 1, 2 up over 1, 2 up over 1. It's the same slope for every point from one point to the next. The second bullet, for graphs other than lines, so your parabola, your square root graph, your sine curve, any of the graphs that we've done this year other than a line, the rate at which the line or the graph rises or falls from one point to the next changes. Because if you have a parabola, there we go, the slope of a parabola or the rate at which that graph rises or falls is different if it's closer to the vertex than it would be if it's up more on the curve. The steepness is going to be different. And that's really what slope is. The slope is the steepness of a graph, the steepness of a curve. So if it's a curve, it's going to be different for every point on that curve. The third bullet, to find the rate at which the graph rises or falls at a particular point, we're going to be finding the slope of the tangent line at that point. So if I have a point right here and I want to figure out what the slope is at that point, because each point has a different slope, we're going to make a tangent line, and we're going to be finding the slope of the tangent line. Because lines have slopes. Curves increase or decrease, but I can find the steepness of that curve at that single point by using the slope of the tangent line. So that's what we're going to talk about today. Just to kind of show you a couple of examples, it says the tangent line to a graph at a point, one point, is the line that best approximates the graph at that point. So a tangent line intersects a circle at one point. Tangent line intersects any graph at one point. A secant line intersects a graph at 2 points. So tangent is 1 point, secant is 2 points. We're going to talk about both of those terms today. But just to give you an idea of what a secant line does, so I kind of showed up here. So we'll just draw that graph again. So if this was my parabola, a tangent line connects the parabola at 1 point. So literally it's just touching the graph at that 1 point. It's still a line, but it doesn't go through the rest of the graph. So that could be one example of what a tangent line would look like. This would be an example of an exponential decay function. Again, I could have a tangent line connecting, oh, that was supposed to connect, try again. The graph at 1 point, but it could be underneath the curve, it still didn't connect. Oh, that looks better, there we go. So it could be under the curve as well, depending on where the curve is. And one final graph, if I have something like this, I could have a tangent line on the peak of the curve as well. So a tangent line can be anywhere on the curve, and it's going to have a different slope depending on where it is at the curve. Our goal today would be to find out what that slope is. So we have analyzed graphs this year by finding out their x-intercepts, their y-intercepts, their max values, their min values, their asymptotes. I think that's about it. Points on the graph, random points wherever they happen to be. That's algebra. To move into calculus, you'll be analyzing graphs differently. So what is the slope at a specific point on the graph? What's the area under the graph, the area under the curve? So you'll still be looking at the functions, but you'll be doing other things with them. So this is kind of taking you to that next step. So how else can we analyze a function? You'll be able to find the max or the min without the aid of a calculator. So like that will be the goal, to kind of take you above the algebra. What else can you do with a curve, a graph? What other ways are we able to analyze it? So today we're going to see about analyzing slope of the curve, specifically just looking at the slope, which is one small concept that becomes a big concept in calc. But we're going to kind of take it piece by piece. So the question says, find the slope of the graph of the following function at the point 1, 1. A lot of the problems that you'll have will have these directions. Find the slope of the graph at a specific point. This means find the slope of the line tangent to the graph at that point, because that's actually what we're going to be finding. It still has to kind of go back with a line. The slope and line go together. So we're going to graph the first function here, y equals, or f of x equals x squared, which we know is our most basic parabola. That's our parent function for a quadratic. So starting at 0, 0, if I go over 1, up 1 because 1 squared is 1. If I go over 2, I move up 4 because 2 squared is 4. I'm going to go up 9 because 3 squared is 9. And then mimic that on the other side. And then I'll connect the points, making my parabola. So the question is, find the slope of the graph at the point 1, 1. So 1, 1 is right here. That's the first point that we have plotted after the minimum of the vertex. Using another piece of paper, a straight edge, a ruler, a calculator, as best as you can, I want you to draw a tangent line through that point. So a tangent line connects the point, it's a straight line, it connects the graph at that one point. So it should not go through, cross the graph at any other point. But as best as you can, that's what we're trying to find. Our goal is to find the slope of the tangent line. So you need to make a line that is tangent to the graph. So it should go through 1, 1, but not the rest of the graph. And then estimate or look at that point and find the slope. So you calculate the slope by starting at the point 1, 1, and then seeing where else it crosses through the corner of a box. So like it looks like mine's crossing through the corner of a box right here. Slope is rise over run. So count from the point 1, 1 up to your point. Yours is going to be different than mine. So look at your graph. Starting at 1, 1, where does your line cross through the corner of a box? How far does it rise? How far does it run? That's your slope. So my slope, 1, 2, 3, 4, 5. My slope is 5/3. And I found that just by starting at 1, 1, going up 5, and over 3 to get to the second point that's on my tangent line. Again, you have a different tangent line, so look at your graph. What's the slope of your graph? Zach, what did you get for the slope of your graph? Zach, take 4 over 3. So Zach got 4 over 3, I got 5 over 3. Zach Strezza, what did you get for your graph?
3 over 2.
3 over 2. So 4 over 3, 5 over 3, 3 over 2. Ethan, what did you get for your graph?
8/5.
8/5. Anybody else?
I got the same as him.
You got the same as Zach?
Yeah.
What did you get?
6/5.
6/5? David? You got 2. So we all have different slopes. So do you think that that's a good method to use?
No.
Probably not, right? I mean, we all have different answers. There's not one that's definitely the same. So we have to try and think, what other ways can we find the slope at that point, besides just kind of estimating? And it depends on the steepness, like how you chose to get that line, where you thought it looked like it was tangent. So method number 2, to try and be a little more accurate, we can use a secant line. So a tangent line touches the graph at one point, but a secant line touches the graph at 2 points that are on the graph. So at least now it's 2 points on the graph. So I'm going to draw the same picture down here using those same points. We're still in the same function here. So point at 1, 1, 2, 4, 3, 9. Now I'm not going to draw the secant line on the graph, but if I'm finding the slope that goes through 2 points, my first point is 1, 1 because it has to go through 1, 1. That's what we're trying to find the slope. Pick another point on your graph. What's the second point on the graph?
0,
0, 0. What else could we use besides 0, 0, Marie? 2, 4. You could use 3, 9, whichever ones you want to use. So we could use 2, 4. You could use 3, 9. Those are the 2 points I'm picking. Zach, yours aren't wrong.
Yeah, I know. I didn't see Marie's hand up.
No, it's okay. That's
Sorry,
all right.
Mom.
So if I did this method, Marie, if we had 1, 1, and 2, 4, what would our slope be? Just looking at this point up to that point.
Oh, 3.
Yeah, my slope would be up 3 over 1 if I had that set of points. If we used Zach's set of points, he said 1, 1, and 0, 0. Zach, your slope would be?
It's 0, 0.
Yeah, it would just be x equals 1.
Yeah, it would just be 1 because you're rising 1, you're running 1. So again, the slopes are different dependent upon the point that you choose. So if I chose this 2 points of 1, 1, and 2, 4, I'll put them next to it here. My slope is 3, but if I pick 2 points that are closer together, my slope is 1. So not quite as accurate, but at least we're using points on the graph. Underneath this, it says the slope of the secant line. So we're going to kind of summarize this in general so that I don't just have to say for these specific points. This point right here that was 1, 1, I'm going to call it the point x, f of x, because now I want to give you a little like summary formula to summarize this. So if I have an x value, I have a y value. The adult way to say y is to say f of x. The pre-calc way to say y is to say f of x. The horizontal distance between 2 points is h. Oop. I guess I should say 2x values. So because I'm kind of going now in general. So if I have a point at 0, 0, and I move some horizontal distance, h, to get to the next point, I would take my current x and I would add that distance of h to get to that next horizontal point. So this point up here is going to represent x plus h, because I'm moving over horizontally some h distance. And therefore, if I apply that to my f, I would also have to have x plus h, because whatever I do to x affects my y. So if I'm here and I'm moving over some horizontal distance h, that x value that I move to get horizontally affects the y as well. So to find the slope of a secant line, does anybody remember how you find the slope of a point? 2 points of a line.
Right, it would be y2 minus y1 over x2 minus x1.
So that's the slope of a line, any 2 points on the line. So now I have these 2 points on the line, wherever they happen to be, and we're going to calculate the slope using those 2 points. So Marie said take y2. Well, y2 is usually the point that's on the right. So you move left to right on a graph. So y2 is this f of x plus h. She said minus y1. So here's y2, here's y1. I would subtract f of x. On the bottom, Marie said x2, well, that's this x plus h, minus x1, well, that's subtracting x. What do you get? David, what do you get? It's going to just be over h. That's the difference quotient. So we've been finding the difference quotient, which is really, what's an I? The secant line of a graph. So the difference quotient that we did at the very beginning of the year, like, whoa, is actually a line that associates a graph. It's the secant line of the graph. So we're going to see if we can try and apply that secant line to start coming up with slopes of curves of any graph. So if you flip yours over, I thought I put a really cool diagram in there, and alas, I didn't. But I have it in my notes, so it must count for something.
You tried.
Yeah, right, I tried. This is also in the book. You would have seen this same diagram in the book, but I wanted to have it in your notes, and it'll be in there for next year. None of you want to take me again next year for this class, trust me. So the diagram on the right side here has those same 2 points that we just looked at. So you have the point x plus h, f of x plus h. You have the point x, f of x. So it's showing you technically finding the slope, taking the rise over the run. That h is the distance horizontally between the 2 points. by using the process of a limit as h approaches 0. That h distance, if it's approaching 0, is going to get closer together. And the closer together my 2 points are, the more accurate it will be. So then over here in graph 3, the distance of h or the 2 points are closer together. And if it approaches 0, essentially that distance of h is non-existent and 1 point is meeting at the other point. That's how we get a tangent line from the secant line. So by using the process of limits, I've taken my tangent line or my secant line, which are 2 points somewhere on the graph, and taken those 2 points and squished them together to be 1 point on the graph. So the only difference from a tangent line to a secant line is that the limit as h approaches 0 is part of the formula, because now the distance between my 2 points is no longer there. That's why we've been doing that limit as h approaches 0. So a secant line doesn't have a limit, but the slope of a tangent line does. And that's the true goal that we're trying to find. What's the slope at 1 point on the graph? Because then I have an exact slope, not an approximate slope. So please make sure you're writing this little definition down. The slope of a tangent line can be found by taking the limit as h approaches 0 of f of x plus h minus f of x all over h. So all this time that we've been finding the limit as h approaches 0, or we've been doing the difference quotient, we're really finding the slope of a graph. And we're going to try and find it at a specific point. So the first question is actually the hardest of the ones that we're going to do today. You might as well start hard and work easy. Right? Why not? Instead of doing the easy one first. And I have a feeling I didn't erase mine. Oh, I did. So find the slope of the graph. That really means find the slope of the tangent line at the following point, which is 312. We're going to ignore that point for now. We're just going to try and find the slope of the graph. And to find that slope, we're taking the limit as h approaches 0 of f of x plus h minus f of x all over h. You will use this little formula so many times at the beginning of next year. So remember that process is to take whatever's in parentheses and go into the function for x. We didn't have any questions like this yesterday. So there wasn't anything about this little formula yesterday. It was just limits, so kind of basic limits on that test. So Katie, what does it look like if we plug the x plus h in for the function?
So it'd be 10x plus 10h.
Oh, hold on, you're foiling it through. Without distributing it through,
Oh.
just by plugging it in.
Yeah. And then it'd be minus 2x plus h squared.
And then the f of x part, that last part would be,
minus 10x plus 2x.
yeah, and I'm just gonna write it like this for now, you are totally right. So the x plus h replaces both x's, you're subtracting the whole function, whatever represents f of x, that equation. And then Katie was giving me the next step where they're distributed through. So she said 10x plus 10h. FOIL first, then distribute. So Katie, if you FOIL x plus h squared, that gives you
X squared plus 2xh plus h squared.
right. And multiply that all by negative 2. So negative 2x squared minus 4xh minus 2h squared. And then we have a minus 10x and a plus 2x squared. So Ethan, in all of these problems, what always happens for us?
They cancel out.
Yeah, you should have all those terms canceling out. Which pairs cancel, Ethan?
Let's see. 10x and negative 10x.
Right?
2x squared.
And then the terms that remain are supposed to have what in common?
All have
Right, all have h's, because that's what's in our denominator. And right now, we can't evaluate the limit because it makes the denominator 0. But if we factor out that h, that gives us a 10, a minus 4x, and a minus 2h. Now we get those h's to cancel, and we can finally evaluate the limit. So at the beginning of the year, our answer would have been 10 minus 4x minus 2h. Now we're trying to find the limit as that h, the distance between the 2 points, goes to 0, so that I have 1 point kind of on top of the other. And we are left with the equation, so take the h, plug a 0 in for h, and we just have that 10 minus 4x. That represents the slope of our curve at any point on the graph, not just at one point, but any point on the graph, this would be the slope of that curve. We can use that slope to find the specific slope at the single point. And they're asking us to find the slope at the point 312. So how would you use that slope formula to find the slope at the specific point 312? What do you think you do? Plug what in? Yeah, the x, because it only has an x in it. So we would plug in the x value of 3, so we'd have 10 minus 4 times 3. So Ethan, our slope at that point would be -2. Questions? So you could find the slope at a different point by finding a different point on the graph and then plugging it in and getting the slope at that point. So just to kind of think about this graph, we have 10 minus 2x squared. The minus makes a parabola that goes down. So my point 312 is probably somewhere up top, and we are trying to find the slope at that point. That's why our slope is negative, because the line is going down. So it's on the side of the curve that's decreasing, so we have a -2 for the slope. Questions? So as I said, that was actually the harder one of the two. Actually 3 on this page. If you look at the second one, we're just going to see if we can work through it again. So our goal is to figure out the slope at a specific point of the curve, because every slope is different. But once you come up with the equation for slope, you can use that equation to find any graph or any point of the graph, any slope. So looking at the second, find the slope of the graph of this function, just x squared. That's the one we started with, at the point -2, 4. So we can find it now at point 1, 1, which is what the original question was asking us to find. But they're asking us to find the point at -2, 4. So finding the slope means we're calculating the limit as h approaches 0, because we're finding the tangent line. So since it's just x squared, we just have x plus h squared. Minus f of x means subtract x squared and then divide by h. So x squared, 2xh, h squared minus x squared all over h. So Marie, what happens here?
We need to do that, the x squared cancels.
And when you factor out an h, what do you have?
Once you factor out the h, you're left with h plus 2x.
Yeah. And when you plug in the 0, you end up just having 2x. So that represents the slope at any point on the graph. We specifically want to find the slope at -2, 4. So Marie, at -2, 4, the slope would be -4. So if you go back, you don't have to flip, but if you go back to the first question asked us to find the slope at the point 1, 1. Same exact equation, because it was y equals x squared. We were asked to find the slope at the point 1, 1. That slope should be, if I plug the 1 in, 2. Did any of you get a slope of 2 when you estimated your line? I think somebody did. Ah! Should rock candy down. David's the winner today. So for the first problem, I'll go back to mine. The first problem we started with was making our own tangent line, kind of estimating where you thought the tangent line should be. I calculated my slope to be 5/3. Aaron, what did you get your slope to be?
I was wrong.
You were wrong. But the actual slope is 2 at this specific point right here. So if anybody calculated the slope of 2, you were good job at drawing your perfectly straight line. Any questions? How would you actually get the oops, right here. So if I knew the slope was -4, how could I actually come up with the equation of that line? So we have this tangent line. How could we actually come up with the equation? Ethan?
Grab the x and the y to that point. Just write it out.
And then what line? What's the equation of a line, Ethan?
Y
Y equals mx plus b. So you know your m, you know your x and your y. You can find the b value and then get the line. Any questions? I didn't bring my folder down, but I know there's still a couple of you. Let me look online. That have a presentation problems to do. Oh, Zach says that's me.
Yeah, one of them.
Oh, both Zachs say that's me.
That's me too.
That's
Mine
me
too.
too.
I feel like I did mine.
I
I
did
think
one.
you're okay.
I know I did one.
I just put the, all of, like I updated grades earlier.
I don't know if I did it.
God, I totally forgot about those. I don't know why. I really feel like I did all mine.
I can try to do one different. I'm pretty sure I did mine.
Yeah, I think I did mine.
I did mine.
It's actually something to do my trade homework tonight.
Because Emily, that's my
Alright.
I think it's
Remember that super easy one that you
Me
really
too.
wanted to do for your first homework?
'Cause both of
I
mine are-
stole it for the second.
Yes, Conrad.
I didn't get
What a great.
Zach, would you like to do one?
I'll do one too.
Yeah, you
I'll do
want
that.
to do both Zachs?
Yep.
Okay. Take that on my thing. You're both confident that you have one to do.
Yes.
Yes.
I'm pretty sure yes.
So 19 or 43?
I think that too.
19,
I'll do 43.
43 then.
Enjoy the
Yeah.
Makes me feel satisfied.
How
many do I have to do for this?
2.
Okay, I'm good.
Both of them have been entered in. So if you've done both, you receive grades for both.
But yeah, I'm 100%
This is taking a long time. I'm trying to set it up.
January.
So Zach Dickinson, Grace, Jared, Kyle, Paige, Zach, Streza, Nina, Hannah, David.
We all have two.
I have to do one.
Did you say me?
We all do
one
No, I just did one.
Yeah, you did.
I think I just did.
Yeah,
one.
Wait, do I need to
You're
do
good.
it?
Hannah, let me check on yours.
Okay.
I don't have my paper with me.
Do you have a book over there?
Yeah.
Take a picture of the book so I can start history.
I feel like I've done one this semester.
Yeah, I have, I don't, I have everything entered in if you've done one.
Oh,
boy.
back now.
Yeah, this is it. The last few pages of the book.
Yeah, I know.
What happened? I heard no boy.
You just added other pictures where oh boy.
I think everybody's done
I have
one.
3 more chem work to do for tomorrow. I have
What?
do all my not attendance, trade notes,
Yeah,
trade
right, you've
homework,
done one.
and all that jazz.
And then I'll give another.
Prob stat homework.
Comrade, how long do you know?
Your research paper is good? No, it's not good.
All of your pages.
It's trash. And I'm